Hey everyone, in today's video we're going to be restoring the power amplifier boards on the Marantz 2250B. Now the power amplifiers are important for obvious reasons on a Marantz receiver. It's what makes the music loud, if you will. It's definitely a good idea to restore these boards because next to the power supply, these boards see some of the highest voltages and currents in the receiver. On models like the 2250B, you have two boards, one for each channel. On lower models like a 2235, you'll just have one board, generally on the right side of the receiver, and that board houses both channels. They're all constructed fairly similarly, and they come apart in fairly similar ways. In this video, I'll deconstruct these and get them to a point where I can work on them. I'll talk about which components I'm replacing and why, and then we'll get it back together and test it out to see if I did it right. Let's go. First thing I'm going to do is I'm going to remove the output transistors. This is an easy thing to do right now because, well, the heatsink is rigid and they come out pretty easily. 2 screws per output. And actually what I'm going to do is I'm going to take a picture of this heatsink here with my phone, and that way I'll know which output goes where, because each output transistor is different from the other. So once you have the screws removed, you just wiggle and pull. And if this insulator comes with it, keep it there. We're going to be applying new thermal compound to that later. There, that one didn't come out, but I kind of got it with the pins there. Put the screws back there. Now I'll do the other side. By the way, is your receiver unplugged? You can get a big ol' shock from these outputs. Wiggle. Alright, now that we have our outputs removed, we can work on removing these brackets here for these temperature sensing diodes. Need a different screwdriver for that. Let's try these guys here. It's a little sketchy. I do not want to strip that. Be really careful not to strip the screw. Okay, we're gonna leave that there because that's not wanting to come off. And if you break those wires, you're in a world of hurt. So don't do that. That one doesn't want to come off either, so we're just gonna leave that alone. Now that I'm at the left channel, I'll remove this shield here. Okay, can we lift this out? We sure can. Look at that. You know, while I'm here, I'm going to remove this cover just because I will later anyways. Yeah, that'll give me a little more room. I should be wearing these, so I'll wear them. Even though I'm not soldering, it's still good practice to wear them. Safety is very important. Please be safe if you're using this to actually do your own work. Now let's start removing the screws that actually hold the circuit boards to the heatsink assembly. And here's another important thing. See, I just removed this thing, and if I take out those screws, they're this long, and if I look at this screw, it's much longer, so we don't want to mix these up. Make sure those stay with the cover, and that these stay with the things related to the amplifier board assembly. Let us also note that we've got a little ring terminal right there. We'll want to make sure we catch that when we put that back. Same thing on the right channel. Get the other 2 screws by going down here. Bring it back down. Okay, we've got our boards loose. Now let's remove our heat sinks. Those are pretty straightforward. Okay, right channel heatsink can probably be removed now. Wonderful. That was really easy. Now let's go. Now that we're like this, we need to be careful whenever we're moving the receiver around that we're not about to clip it on anything like that. Sometimes the heat sinks on these just don't want to come out. They want to have some reason to fight you. So here, we're fighting the inability to move around here, and then we're getting caught on this solder joint right here. Oh, You know what it's running into? See, here's what I think happened with this receiver. I think that somebody bought this receiver because it had a wood case. You know why I think that? Because it's got wood case screws on all the feet. And true Marantz enthusiasts know that you cannot use these insanely long screws without a wood case. Because, well, one, I couldn't get that out just now, and two, I'm not gonna really try too hard to show it on camera, but I'll tell you right now, this screw right here, it's shorting out these dubbing ports and it's shorting out the headphone jack. And it's just infuriating seeing this happen to so many Marantz. Okay, that's my rant for this video, for now. Now that that's out, let's see if we can move this. Oh wow, would you look at that? Comes right out. Stupid screws. I'm gonna have to get new screws now. Okay, disassembly is complete. Mechanical disassembly, at least. So what this is a screenshot from the service manual. Both of these are, and this is the components list, at least part of it. I printed out the section that has the capacitors. You see they all start with C in their component designator number. And then the semiconductors start with the letter H. And those are what we're concerned with. The resistors, resistors don't really go bad unless something bad happened and it burned up and it's either open or, a short circuit at that point. Electrolytic capacitors are filled with a fluid, literally, and that fluid dries up or goes bad. So we're only going to be concerned with these guys right here, these electrolytic capacitors. And as you can see, there's 5 of them. Capacitors exist in this amplifier in 2 ways. One, they could be part of a power circuit, or they could be part of a signal circuit. So let's look at C701 right here. We see that, first of all, J701 right here, this is basically preamp out right here. Your main in jack on the back of the receiver, that's exactly what that is, J701. So obviously this is the audio signal path, and we see that very first thing it does is hit up C701, which is a 3.3 microfarad 25 volt capacitor. Now that looks like this originally. This is the original capacitor. I've already pulled it. And what we do these days with restorations in 2020, or 2021 now, is we like to use film capacitors in place of these electrolytics. We do this because film capacitors are really good for signal path circuits, and they supposedly make things sound better. Now let's look for C702. We see that C702 is right here. So we see that C702 is in parallel with a Zener diode. So that means we will use an electrolytic capacitor like a Nichicon PW series, and that will keep things working well right there. This is the original capacitor. As you can see, it's a 10 microfarad 35 volt. We're going to step that up to 50 volt because, well, that's what I have. And it's not going to hurt anything to step up from 35 to 50. That's totally fine. C704 electrolytic capacitor. Let's take a look. We see that it is right up here. Now this one, I'm not really sure, but I do have a clue as to what it might be. C704 looks like this originally, and I have a theory here. I don't know this for a fact, but I think that on these original capacitors, these orange guys here, they're better suited for an audio circuit, and the gray ones are better suited for a power circuit. So that's why I'm going to use a Nichicon PW, because I think this capacitor is mostly involved with a power circuit. Next we have C705. And again, if we look right here, we see that Marantz has spec'd out a tolerance for this capacitor, just like they did for the 3.3 that's in the audio circuit. So that to me tells me that this is probably in the audio signal path. So I'm going to use a Nichicon KA series capacitor. Nichicon KA series are kind of like LNS Silmic 2s. They're really good for audio circuits. Now the very last one, C706, that's right over here. And again, we see that this is pretty close to a ground circuit. Probably has something to do with power, so we're going to use a Nichicon PW series. And let's just highlight that for good measure. Okay, so now let's discuss the semiconductors here. That's going to be you guys that start with H right here. So I've vetted these already, and we're definitely going to be replacing the Zener diode, which is this WZ177. We're going to be replacing these guys here because they are our differential paired transistors. These guys, I'll get into that in a minute. We're going to be replacing these varistors here. And we're going to replace all of the other diodes here. And then the other transistors we'll be replacing are H711 and H710. I'm not going to touch H707 or 714 and 715. Because these are different transistors. They, I think they might be driver transistors, these guys, and this guy might be the bias transistor. H707 is, yeah, probably the bias transistor. So those are unique part numbers that I don't see easy matches for, and the amplifiers appear to be working just fine, so we're going to leave those alone. And we're also going to leave these guys alone too. They're not in this list because they're not on this board. You see this dotted line, they are external. And what those are the output transistors. It's these guys right here that you see on the side of the heatsink. So that's what those are. These have the most voltage and stuff going through. And also, these don't need to be replaced unless they've gone bad. These are pretty hefty, they last a while, and they say Marantz on them. You can't get that anymore, that's for sure. So let's start up here with WZ177. That is going to be right here. And this is a half watt, 17.7 volt Zener diode. Now since I just have a lot of parts on hand, I buy them in multiples. I looked through my parts and I saw that I have an 18 volt 1 watt Zener diode. So I thought, is 18 volts going to be okay? Yes, because when this was running, I turned this on and I measured the voltage at H701 and it was 18 volts. So I know that this Zener diode is going to be good for this. Going from half watt to 1 watt, that's pretty good. There's nothing wrong with that. It's kind of like going from 35 volt to 50 volt on a capacitor. So that's what we're doing right there. H702 and 703. These guys are quite important. These are what you call the differential pair. And you can see they have a common emitter, and they're trying to balance out the DC and keep this at 0 volts right here. This is very important. And the easiest way for this to happen is if you have transistors with a matched gain. So here's what I've got here. I've got 2 replacement transistors. These are going to be KSA 992s, and they have been tested with my Peak Atlas DCA55 semiconductor component analyzer. And what I do is I buy 100 of these things. I will test all of them. I'll hook them up just like this, and then I'll write the gain on the paper right here. So that way, when it comes time for me to find a matched pair for a differential pair, I just look at those numbers, I find 2 with the same number, and then I'm good to go. I've already done that for the other channel too. I've got these ready to go. Next we'll move on to these varistors, MV13s, H704 and 705. That'd be these guys right here and right here. As you can see, it looks like 2 diodes in series, and if you go on the forums, you'll see that a good replacement for MV13 is 2 1N4148 diodes in series. So here's 2. And all I'm going to do is I'm just going to take these guys. I'll make sure anode and cathode are lined up. You know, we want them to be in series. See those black lines right there? And then all I'm going to do is I'm going to twist them like this. And then what I'll do is I'll take my soldering iron, I'll put a little bit of solder right there and then cover it with a little bit of heat shrink. And then I'll be able to just put this component right in the board, just like this. And I'm going to do that 2 times. I'm going to the rest of these diodes here, they just need to be replaced with a 1N4148. Now these transistors right here, These are more transistors, the same package as the differential pair. You call this a TO92 package. H710 is going to be replaced with a KSC 945, which is this one right here. You're not going to be able to see it in the camera, but it does say 945 on it. And then H711 right here will be replaced with this guy, which is a KSA 992, which is an excellent replacement for 2SA 733. I know this because if you go online, people have spec'd out these transistors and found good replacements for them. So that is my brief explanation on what parts are going where and why. Now if you've never done this before, you might be thinking, how the heck do I know where to put these dang things? Well, look closely at the board here. You can see C706 is right there, so you know that the replacement for that goes right there. Look at our differential pair, H703 and 702. They're both right there. They're going to be pretty easy to get to and replace. I was actually just getting ready to put the power amplifier board back together on the left channel here, but then I realized, well, I've got the covers off of these FM boards, and not having this heatsink here is going to make it a lot easier to recap these boards here since there's so much open space. So I'm not going to put this together just yet. I'm going to break the rule. I'm going to restore more than one thing before turning it back on, and I'm comfortable with that. And that's all I have to say about that. So, and look at that. I've got full access to the bottom of this board here. I'm not going to record myself or make a video on doing these FM boards, but all I'm going to do is I'm going to make it so I can access the bottom of each circuit board, and I'm going to replace every electrolytic capacitor and every tantalum capacitor, which is these blue things that you see on these boards. Those also get replaced just like an electrolytic because they're not reliable when they're old. Alright, got the top tuner boards taken care of. Okay, so I've got my heatsink installed, but I still have the board loose and I don't have my outputs installed yet. And that is because we need to apply fresh thermal compound to the outputs. So the way I'm going to do that is I'm going to use Dow Corning 340. And then I'm going to use a Q-tip to apply it. It's probably a better tool than a Q-tip, but that's just what I'm going to use. Now, first thing I need to do is I need to separate these insulators from the transistors. The actual case, this entire outside case of this TO3 transistor is electrically hot. It is the collector. So basically what this insulator does is it makes sure you're not grounding the collector to the heatsink. So it's extremely important that this is there. Now sometimes people replace these, and I do have replacements for these, but since this receiver is kind of a beater and I'm only doing it for me, I'm just going to wipe these down clean and reuse them. So what I'll do is I'll apply some compound to the back face of these transistors, not very much. I'll put the dry insulator on, then I'll put some compound on the exposed side, and then I'll put the whole thing in the heatsink. And since the board is loose, I can kind of take these, take the little sockets they go into. They just plug right in here. And then I can kind of hold them to the heat sink with my fingers, like line them up in the holes just like that. And then I'll be able to push the output in with no problems and get the screws in there so that the output can be secured to the heatsink with fresh thermal compound. Also, you'll want to apply a little tiny bit to this guy right here where it touches the heatsink. And when you're doing this, be very careful you don't crack the insulator. And also inspect it just to make sure it's okay, because like I said, you really don't want to have your output transistor collector being grounded to the heatsink. That will almost certainly blow a fuse on the receiver. It's not something you want. Okay, this is the moment of truth. I have finished restoring the power amplifier boards on the 2250B. Can't see this one since I've got the noise shield back in place. And, you know, probably should have left those off until I confirmed everything is working. But without further ado, I've got my receiver on the dim bulb. That's why I didn't turn on when I turned it on. But I'll flick the switch down here and we'll see if we get a bright light. We do not. The relay clicks in. That's excellent. Checking for smoke. I don't see any smoke. I've got the volume down. I'll turn on the speakers. There's no noise, which is excellent. Now I just restored the radio boards too, so I'll turn that on. Tunes to stereo. Seems to work. Seems to work just fine. There's no royalty-free music on the radio as far as I know. Okay, it's time to do the power amplifier adjustments. This is especially important to do because we've just, you know, changed everything. So the first thing we're going to do is check the DC offset. To check the DC offset, you're supposed to have no load attached to the speakers per the service manual, and then you just measure the DC voltage between ground and the positive speaker terminal. I'll put it on the right channel, and I see that we have 0.036 volts. That's not zero, so we're going to get that to 0 by turning R707 with a little screwdriver here. So, okay, after some finagling, I was able to break that paint or whatever loose and get it so I can turn this thing. So let's bring our voltmeter back. Okay, now we're at negative 0.029. That's the wrong way. So let me just turn this until I get 0 here. 1 millivolt, 0. That's pretty damn good. I can live with that. Okay, let's go over to the left channel. At the left channel we see 0.13. So I'll go find R707 over here, and I'll just just kind of break it, and then I'm going to turn it until I get 0. I'm going to call that good. So that's the first adjustment. Next, what we're going to do is adjust the amplifier bias. The pins we need to measure across on this bottom edge here. Okay, so the service manual says to adjust between J708 and J710, which is that one and that one. So I'll connect the one to 710 here. And I'll just take my voltmeter with me so I can see. We see that we are at 7 millivolts. That's okay. We're supposed to be at 10. So I'm going to adjust until we are at 10. So what I'll do is I'll bring the trimmer pot down to 0 just to start. Yeah, with my left hand I'm adjusting whatever it is. The one that's not for DC offset. And I'm just going to bring this up until I hit 10. That's 10. Okay, let's go to the next one. I'm leaving that alone. I'm not going to do anything because that's just totally fine. And there you have it, folks. Amplifier adjustment. Now the next thing we'll do is we'll play some music through this for a little while and get it warmed up, and then we'll recheck these same adjustments to make sure that they actually are where they're supposed to be. So that is it for this video. Thank you so much for watching. Next video we will be tackling the phono preamp and the preamp. The preamp is going to be really cool because I have the Sparkos Labs BA312 upgrade kit, and I've never tried it before, and I'm really excited to see what the results are like when I install it on this 2250B. Don't forget to subscribe if you haven't already, and I'll see you in the next video.